Hello, Chem 116 students. It's time for a short conversation about halogen-containing compounds. We didn't have time enough to devote to this in class, but it's worth some consideration if you've taken the time to listen. The alkyl halides are simply those places where a halogen has replaced a hydrogen in one of the hydrocarbons. There are numerous examples that we already described in chapter 12 with halogenation of alkanes. There can be named two different ways, either by common names or IUPAC names. You won't be responsible to understand or produce common names, but they sometimes make sense. In general, we're going to consider primarily the IUPAC names, where you simply put a prefix on an alkane type name and then describe how many or where they're located. So chloromethane is quite simply CH3Cl, and you don't have to think any harder about where to put it because there's only one carbon. So if you wanted to call it by its other names, fine, but no one's going to ask you to know them for sure. The key thing to understand about halogen-containing compounds that makes them unique and interesting so far is that they are very much higher boiling compounds. They have higher boiling points, meaning that they're going to stay liquids in general, and you'll have to get them quite warm to boil them. And they're far less flammable than a lot of alkanes from which they would be derived. And less flammable is a good thing considering how many compounds we've encountered to date in our conversations about organic chemistry that are flammable. So as alternatives to alkanes, they can be much less hazardous to work with. So there are some examples shown here, primarily straight out of your text, which you can find answers for in some cases, but let's just talk our way through a couple of them. They should be obvious after we look at them, I think. The top one there top left has 3 carbons with a chlorine, so 3 carbons is the same as it always is. It's propane. And if you put the chlorine on it, you have to specify where, because it could be on more than an end carbon, it could be on a middle carbon, so 1 chloropropane is the chlorine on the end. The one at the top right is the one I showed similar to the one on the previous slide, but not quite the same. And I believe I need to pause on this one for a moment. So this compound is not quite the same as the previous page because it's got 3 chlorines on the carbon, so that would be trichloromethane. There's no way to number them. They're all on the same carbon. The one in the middle on the left is also from your text, worthy of a moment's conversation. If you consider how many carbons are present, there would be 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 across. Yes? And so either way you count it, the substituents are going to be on a 2 and a 5, and you have to choose which one is going to get the 2 and which one's going to get the 5. And in this case, the name is chosen to put the lower number on the bromine as follows: 2-bromo-5-methyl hexane. It does seem a little arbitrary, but the lowest numbers going to a alphabetically prioritized substituent is consistent with prior naming discussions. The next one at the lower part of the screen brings out another interesting point. If you have a cycloalkane, and yes, the answers are in the back of the book for this one, the substituents are going to be described as simply attached to that cycloalkane. And in this case, with both the chlorine and an ethyl group on the same carbon, you have to specify them in alphabetical order and with a number to explain where they sit, because they could be on the same carbon or they could be on different carbons. If they're on the same carbon, we give them each a 1, and alphabetical order puts chloro before ethyl. The last one on the bottom right, B, there has lots more carbons than the other one, so 1, 2, 3, 4, 5, 6, 7 carbons. Again, this is a little bit like the one prior where we had bromo and methyl, but you can't decide which end is going to give you lower numbers. Well, because you don't, and you're going to get the same numbers either way, so this one's going to be 3 and this one's going to be 5, or vice versa. But let's give the 3 to the one with alphabetic priority, and that gives you a 3-bromo-5-methyl heptane. Okay, names aren't so bad for alkyl halides. The worthy part of the conversation then is to note where these show up biologically. There are some important biological applications, specifically in one particular compound called thyroxine, its thyroid hormone. And iodine is required in your diet to get proper levels of this thyroid hormone, because without iodine, you can't put iodine into that structure. Iodine is not available commonly in diets of people who live away from seafood, and so we have iodized salt to help provide enough iodine to keep us producing sufficient amounts of active thyroid hormone. Without it, you get some bizarre looking disease conditions which you wouldn't wish on anyone. You can tell that this is simply a halogenated aromatic ring in thyroxine 4 places. And yeah, it's got some other interesting features. Yeah, there's an ether in the middle and an alcohol, and you could name those functional groups if you tried. At least I certainly hope so. All right, past that, there are industrial examples, many years worth of use as solvents with chlorinated and halogenated compounds. Dichloromethane is the first one, and trichloromethane, like we mentioned earlier, are used as solvents. And there are examples where chlorinated compounds have been used as pesticides. If you've ever heard of DDT, which is shown at the lower right in the diagrams on this slide, was used to try to combat malaria and typhus and the mosquitoes that transmitted it. Caused a lot of problems in the food chain, and in ecological sense was nearly responsible for the demise of the American bald eagle for a long time. Thankfully it has been, they have recovered. So pesticides include some of these chlorinated compounds. If you're a farmer and you know about these things, you might have heard about 2,4-D, and I'm not quite so sure where Cap10 is familiar, but they all have chlorines in them. Chlorofluorocarbons are those compounds that are also known as CFCs or freons, including freons that have been implicated in depletion of the ozone layer, and they've been banned in the U.S. for quite a long time now as aerosol propellants, but they can still be used as refrigerants. And the problem is they've been banned in the U.S., but not necessarily in all other countries, so there's some issues in environmental concerns there. Primarily because these things, once they're released into the environment one way or the other, they persist. They are very poorly biodegradable, and so they don't manage to be destroyed by ordinary biological, biochemical means, and they persist in their active forms and can cause hazards. All right, enough to know about the alkyl halides, other than to say that they were noted today in class briefly when we talked about inhaled anesthetics. Alternatives to ethers that are less flammable are the ones that are halogenated ethers. They're far less flammable than the hazardous ethers that originally were used as anesthetics. Good luck with your studying. I hope it all comes together well for you so you do well on the test.